Technology Risk Part 9. This episode has 19 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. GCP Landing Zone. How would you design the GCP organization, folder, and project hierarchy? Here's a strong way to approach it. I would align the hierarchy to governance and operating model. A common structure separates production, non-production, shared services, security, networking, data, and sandbox environments. Projects should have clear ownership, labels, billing mapping, and environment boundaries. Folder-level IAM and org policies should be used carefully so controls are inherited consistently. Nice. Let's continue. Question 2. GCP Landing Zone. Which GCP organization policies would you enforce as part of a secure baseline? Here's a strong way to approach it. I would enforce policies such as disabling service account key creation, restricting public IP usage where appropriate, blocking public access to storage, restricting allowed regions, requiring shielded VMs, controlling external sharing, restricting domain identities, and limiting resource locations. The exact policy set should match business, compliance, and application requirements. Great. Moving on. Question 3. GCP Landing Zone. How would you design IAM and access management for a landing zone? Here's a strong way to approach it. I would use groups instead of direct user grants. Avoid basic roles, separate admin, developer, security, network, and audit roles. Use least privilege. Enforce MFA through identity provider. Prefer service account impersonation. Avoid long-lived keys. And review access regularly. Privileged access should be approved, time-bound, logged, and monitored. Alright, next question. Question 4. GCP Landing Zone. How would you design networking for a GCP landing zone? Here's a strong way to approach it. I would use shared VPC for controlled network ownership, separate host and service projects. Define IP ranges carefully. Use hub and spoke connectivity, private subnets, cloud NAT or controlled egress, firewall policy, private Google access, DNS forwarding or peering, and hybrid connectivity through VPN or interconnect. Network changes should follow review and approval workflows. Let's keep going. Question 5. GCP Landing Zone. How would you implement centralized logging, monitoring, and audit evidence in a landing zone? Here's a strong way to approach it. I would create aggregated log syncs to a central logging or security project. Export critical audit logs to BigQuery or SIM. Enable VPC flow logs and firewall logs where needed. Define alerting for risky changes. And retain evidence based on compliance requirements. Key events include IAM changes, org policy changes, logging changes, firewall changes, and public exposure. On to the next one. Question 6. GCP Landing Zone. How would you manage security controls such as SCC, KMS, Secret Manager, vulnerability scanning, and policy as code? Here's a strong way to approach it. I would enable Security Command Center for posture visibility, use KMS for key management where required, store secrets in Secret Manager, enforce vulnerability scanning for images and workloads, and use policy as code in Terraform or CI or CD to block risky changes before deployment. Findings should create own tickets with severity and SLA. Good. Here's another one. Question 7. GCP Landing Zone. How would you handle billing, budgets, labels, cost allocation, and FinOps in a landing zone? Here's a strong way to approach it. I would require labels for owner, app, environment, cost center, and data classification. Configure budgets and alerts. Separate billing views by project or folder. Monitor cost anomalies. And define chargeback or showback. FinOps control should be part of onboarding so cost ownership is clear from day one. Nice. Let's continue. Question 8. GCP Landing Zone. How would you onboard new application teams or projects into the landing zone safely? Here's a strong way to approach it. I would use a project factory or standardized Terraform module that creates projects with baseline IAM, labels, APIs, logging, budgets, network attachment, org policies, and security controls. The onboarding workflow should capture owner, environment, data classification, connectivity needs, approvals, and exception requests before the team starts deploying workloads. Great. Moving on. Question 9. GCP landing zone. What are common risks or anti-patterns in GCP landing zone implementation? Here's a strong way to approach it. Common anti-patterns include flat project structure, broad owner access, manual project creation, no labels, inconsistent logging, public buckets, unmanaged service account keys, ad hoc VPC peering, no cost controls, weak exception tracking, and controls that exist on paper but not in CI or CD or Terraform. These create audit gaps and operational risk. Alright, next question. Question 10. GCP landing zone. How would you assess whether an existing GCP landing zone is mature and compliant? Here's a strong way to approach it. I would assess organization hierarchy, IAM, org policies, networking, logging, monitoring, billing, security findings, project onboarding, incident readiness, backup, DR, and evidence quality. I would compare current state against a control baseline, sample projects for compliance, review exceptions, identify systemic gaps, and create a prioritized remediation roadmap. Let's keep going. Question 11. Multi-cloud networking. How would you design secure network connectivity between GCP, AWS, and Azure? Here's a strong way to approach it. I would start with business requirements, traffic flows, data sensitivity, latency, compliance, and ownership. Then I would design a hub or transit model using GCP Interconnect or VPN, AWS Direct Connect or Transit Gateway, and Azure Express Route or Virtual WAN. I would enforce segmentation, least privilege routing, firewall controls, DNS governance, encryption where needed, logging, monitoring, and clear change management. On to the next one. Question 12. Multi-cloud networking. What are the main connectivity options for multi-cloud networking, and when would you choose VPN versus dedicated connectivity? Here's a strong way to approach it. Main options include site-to-site VPN, dedicated connectivity such as Cloud Interconnect, AWS Direct Connect, Azure Express Route, Partner Interconnects, SD-WAN, and third-party network appliances. VPN is faster to set up and cheaper for lower throughput or backup connectivity. Dedicated connectivity is better for predictable latency, higher bandwidth, lower jitter, production workloads, and stronger operational SLAs. Good. Here's another one. Question 13. Multi-cloud networking. How would you plan IP address ranges to avoid overlap across multiple cloud providers and on-premises networks? Here's a strong way to approach it. I would create a centralized IP address management plan before connecting networks. Each cloud, region, environment, and business unit should have allocated CIDR ranges with room for growth. I would avoid overlapping private ranges, document ownership, reserve ranges for shared services, and validate new VPC or VNet creation through Terraform or policy checks. Nice. Let's continue. Question 14. Multi-cloud networking. How would you design routing between GCP Cloud Router, AWS Transit Gateway, Azure Virtual WAN, and on-premises networks? Here's a strong way to approach it. I would define approved route domains, route propagation boundaries, BGP policies, priorities, failover behavior, and summarization. Cloud Router, Transit Gateway, and Virtual WAN should exchange only required routes, not everything by default. I would avoid accidental transitive access, monitor route changes, document traffic paths, and test failover before production dependency. Great. Moving on. Question 15. Multi-cloud networking. What are the security risks of transitive routing in a multi-cloud network? Here's a strong way to approach it. Transitive routing can accidentally allow one environment or cloud to reach another through a shared hub. Risks include lateral movement, bypassing inspection points, production to non-production exposure, third-party overreach, and data exfiltration paths. I would control this with segmentation, route filtering, firewall policy, identity-aware access, logging, and explicit approval for each connectivity path. Alright, next question. Question 16. Multi-cloud networking. How would you design DNS resolution across GCP, AWS, Azure, and on-premises environments? Here's a strong way to approach it. I would define authoritative zones, forwarding rules, private zones, split horizon behavior, and ownership. GCP Cloud DNS, AWS Route 53 Resolver, Azure Private DNS, and on-prem DNS should be connected through controlled forwarding paths. I would avoid duplicate zones, document resolution flow, monitor DNS failures, and protect sensitive records with access controls. Let's keep going. Question 17. Multi-cloud networking. How would you segment production, non-production, shared services, and third-party traffic across multiple clouds? Here's a strong way to approach it. I would segment by environment, trust level, business unit, data sensitivity, and regulatory boundary. Production should not have broad connectivity to non-production. Shared services should expose only required ports. Third-party connectivity should be isolated with strong firewalling, root controls, logging, contracts, and periodic access review. Segmentation must be tested with connectivity validation. On to the next one. Question 18. Multi-cloud networking. How would you design centralized ingress and egress security controls for multi-cloud workloads? Here's a strong way to approach it. I would define where internet-facing ingress is allowed, use WAF and load balancer controls, restrict public IPs, and centralize egress through NAT, proxies, firewalls, or inspection appliances where required. Controls should include TLS, allow lists, threat detection, logging, DLP where needed, and clear exception handling so teams do not create unmanaged bypass paths. Good, here's another one. Question 19. Multi-cloud networking. How would you monitor multi-cloud network connectivity, latency, packet loss, route changes, and availability? Here's a strong way to approach it. I would collect metrics and logs from VPN tunnels, interconnect, direct connect, express route, cloud router, transit gateway, virtual WAN, firewalls, DNS, NAT, and load balancers. I would monitor latency, packet loss, tunnel status, BGP session state, route changes, drop traffic, DNS errors, and bandwidth saturation. Alerts should be tied to service impact and ownership. Nice, let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.